What up everyone, this is LeetCode 141, linked list cycle. So we're given the head of a linked list and we have to determine if the linked list has a cycle in it. So there's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. So, right, at this 3, go to this 2, go to this 0, go to this -4, and then we go back to this 2, right, and continually go back to this 2 because there's a cycle in the linked list. Now, the way to solve this problem is actually kind of hard if you've never encountered the algorithm used to solve it. So don't feel bad if you can't intuitively come up with the algorithm. It's like one of those algorithms that you learn once and then you kind of keep it in your back pocket forever, which is nice. But the first time you encounter a problem like this, where you have to detect a cycle or any similar type of problem, it's a little bit hard if you don't know the algorithm that's used in this specific problem, but it's called the tortoise and hare algorithm. Okay. Now, what we're going to do with this algorithm is we're going to have a slow pointer and a fast pointer, and they're both going to start at the head node. And for each iteration in a while loop, the slow pointer is going to move one, right? One unit, or one to the next. And the fast pointer is going to move twice. So it's going to go boom, boom. So the slow pointer moves once, fast pointer moves twice per iteration. Okay. If there's a cycle in the linked list, at some point, the slow pointer and the fast pointer are going to be equal to each other because they're going to meet. Okay. If the slow pointer and the fast pointer are ever equal to each other, meaning they met, we know there's a linked list cycle. So we can return true, right? Because they met. So we know there's a linked list cycle. So we return true because there's a cycle in the list. Now, when would we return false? We know that there would be no linked list cycle if our fast pointer at some point reaches null or fast.next reaches null, right? So, right, let's say this 4 didn't have this cycle, it's just, it ended here, right? Our fast pointer would go 1, 2, okay. Fast is not null. Fast.next is not null, so go again, 1, 2. Okay, at this point, fast is null. So we know there can't be a linked list cycle because we hit a null node. So we'd return false. Okay. So yeah, tortoise and hare algorithm. Kind of hard to come up with on your own, to be honest. But like I said, it's one of those things you learn once and then, you know, it's you know it for the next time. So don't feel bad if you couldn't come up with this algorithm on your own. I certainly couldn't. This is the first problem where I learned this algorithm. So anyways, we're gonna say, well, let's handle an edge case first. Root is equal to null. Sorry, not root, head. Our input parameter is called head. The reason we do this is because the number of nodes in the list can range from 0 up to 10 to the power 4. So we can have 0 nodes as in our linked list, so we just return false because it can't be a cycle in that case. Here we would make a node called slow, set that equal to head, and a node called fast, set that equal to head, right? They both start at the head node. And we're going to say, okay, if fast is not equal to null and fast.next is not equal to null, then let's traverse, okay? So we're going to say slow, and again, that's going to move once. Fast is going to move twice, so we're going to say .next, okay? Now we're going to check if slow is equal to fast. If they meet at some point, we know there's a linked list cycle, right? If we exit this while loop, it means that the fast pointer hit a null node or fast.next is a null node. So we know there's no linked list cycle, so we return false. Oops. Oh, right. Typo. My bad. So yeah, that's the tortoise and hare algorithm. Kind of hard to come up with on your own. By the way, here, like, You can do auto as well. Like, I don't know, like some people just use auto if you want to make it easier. And you don't know what type the pointer should be. I mean, you know this just because we know this is a linked list, but still a useful keyword in some problems, right? But yeah. Anyways, yeah, it's a tortoise and hare algorithm. Kind of hard to come up with on your own, but you learn it once and then you know it for the next time. So there is a problem. We're doing the grind 75 list right now. There is another problem down the line where you have to use the same type of algorithm. The problem is different, but the approach is similar. So just keep that in mind. This algorithm isn't just specific to this problem. It does show up more than once in different problems. So it is a useful algorithm. But anyways, I hope this helped, and I'll see you in the next one.